Okay, so let me let me make those comments again, right? So, so today we're going to go over sections 10.1 and 10.2, which are on the law of sines and cosines, right? So basically, so these two sets of formulas will allow us to handle triangles that are not right triangles. Okay, so that'll be what we're going over today. So other things we should know in the last week of the course is that again, so Friday will be the final exam in the course, which will cover everything that we've done previously. So in terms of the final exam, I don't plan on putting up any review problems or or study guides specifically for the final exam, right? So there's already the tests 1, 2, and 3 review that are available, and all the notes from the previous sections that you can use to review for the final exam.
Is final exam is on My Open Math?
Yeah, the final exam will be on My Open Math, similar to the previous two tests. So another thing is that, again, because this is the last week of class, so in terms of the My Open Math, the homework problem sets that we've had for all of the previous chapters will close at the end of this week on Friday. So if there are any previous sections that you still need to finish up, you should finish up by Friday.
What?
So I was just saying that if you have any My Open Math homework that you didn't do previously, they need to be done by Friday, because Friday is the very last day of the class. And so whatever is done by then will be considered in your final grade. I think in terms of the homework, it should be something like out of 295 points total or something
It's
like that.
15% of our final grade.
I'm sorry?
It's 15% of our final grade.
Yes, yeah, the My Open Math is 15%. So it was worth a little bit less than an individual test.
The test is Thursday, right?
It's Friday.
Friday, yeah.
Okay, and any other questions before we begin?
How long will the test be?
I haven't completely decided yet, but it's probably the same length as the other tests.
Okay.
Okay, so let's go over chapter 10, which again is on the law of sines and cosines. Uh, so previously, when we introduced the 6 trig functions, right? So sine, cosine, tangent, cosecant, secant, and cotangent, we use them mainly to deal with right triangles, right? So where one of the angles is a right angle and is 90 degrees, but not all triangles are right triangles, right? So how do we deal with triangles that are no longer right triangles, right? So triangles that are not right triangles are called oblique. So that's what we're going to discuss today, right? So the law of sines or law of cosines, or both of them, to solve these kinds of triangles, and which one we use. What is a your network causing poor call quality? Well, I can't do. Okay. So you can use either the law of sines or cosines, or sometimes both to solve these kinds of triangles. And which one you use will depend on which angles and which sides we know from the triangle. Okay, so first let's talk about the law of sines. So so the discussion here at the bottom of the page is just going over how to derive the law of sines. So here you have a triangle that's not a right triangle. Okay, but as I've mentioned previously, when we use the trig functions, we want to deal with right triangles, right? So what we can do in this triangle is to split it into 2 pieces, where each piece is itself a right triangle, right? So if you draw the altitude here, which I've called y, vertically to the base, perpendicular to the base, right? So then we have a small right triangle on the left and a small right triangle on the right. And now because each of these 2 smaller triangles is a right triangle, we can then relate the sides, say using sine, right? So for angle A, opposite to angle A is y, and the hypotenuse in this smaller triangle is b, right? So we get sine of A is equal to y over b, and then similarly on the triangle to the right, opposite to angle B is again side y. So you can say that sine of B is y over A. Okay, so looking at angles A and B, we've related it to both of them to side y, and so you can put the 2 equations together, and right, so this one you just multiply by B to get y equals B times sine A, and similarly here you multiply by A to get y equals A times sine B, and then because both equations are equal to y, they have to be the same, right? So they have to be equal to each other. And then we can just simplify this expression by dividing by B over here and then dividing by A over here. And then the formula becomes sine of angle A over A is equal to sine of angle B over B. And so this is the law of sines, right? So basically what it does is it relates the 3 different angles together along with their corresponding sides, right? So the side A is always opposite angle A, and then similarly for the other sides. So the law of sines becomes sine of A over A is equal to sine of B over B is equal to sine of C over C, right? So where the capital letters are the angles and then the lowercase letters are the sides. Okay, so the law of signs is pretty easy to remember, right? So the angles and the corresponding sides should always go together. And you can write it with the angles in the numerator and the sides in the denominator, or in the reverse, where the sides are now in the numerator and then the angles are in the denominator. Okay, so so that's the law of signs. So how do we use the law of signs? So as I said previously, it depends on which sides and angles are known in the triangle. That'll tell us when we can use the law of signs. Okay, so the types of triangles for the law of signs is, so the cases are where the first case is where you have either an AAS or an ASA triangle, right? So A stands for angle and then S stands for side, right? So if you have a triangle where you know one side and two angles, then we can use the law of signs. And the other situation is for an SSA triangle, right? So side, side, angle. So where you know two sides of the triangle and one of the angles that are not between the two sides. So this second case is a little bit trickier because in the case of an SSA triangle, there's a possibility that you have either one, two, or no solutions, depending on how the calculations turn out. So this situation you want to be careful about.
How could you have more than one solution? Aren't you looking for one thing?
Wait, can you repeat the question again? I didn't get that. Can you
How
repeat
could
the
you
question?
have more than one solution? Aren't you looking for one thing? Looking for a side. How can a side have more than one answers to it?
So the reason is because typically in these problems you have incomplete information, right? And you'll run into a situation where there's two possible triangles that can have the same information. So what do I mean by this? So let's say, so you know two sides and an angle, right? So so say you have so in a triangle that looks like this. Let me draw a little bit bigger, so it's a little bit easier to. Right, so by SSA, for this triangle, what I'm referring to is these two sides and this angle here. Okay, so SSA. So I can draw this triangle this way, or I can spread the side on the right farther out. So that looks kind of like this. So let's call this S1, S2, and A. So this is S2 and A. I didn't draw this example very well, but in any case, this is essentially the situation where I can draw two different triangles that have these same side lengths, and then angle A is the same, but the top angle and then the other angle is different. And so you can have, so basically the unknown sides can be different in these two triangles. Basically, the reason this happens is, if you remember from geometry, there are different situations where you have congruent triangles. So for an ASA triangle, right? So if you have two triangles where you know one side and two angles, then the two triangles have to be congruent. But that's not the case when you have an SSA triangle, right? So if you know two sides and one of the other angles, the two triangles don't necessarily have to be congruent to each other, and that's why there's two solutions.
Professor, is the final exam last for like 1 day full, or like last time?
What do you mean?
I mean, is it is it like in our ordinary time, like 8 to 9, 10 p.m., or it will last for that day?
Well, you can start it within the day, but there will still be a time limit. I mean, you can't just work on the problems all day long.
Got it.
Right, so
Thank you.
like test 3, you could have started it either Friday or Saturday, but still you only had 3 hours to do it, right?
Yes, thank you.
Okay, so these are the situations where when we want to use the law of sines. So so here I've already done this example. Right, so here this is an AAS triangle, right? So as I said before, you know, two angles and one of the sides, right? So you're given that angle A is 34 degrees, angle B is 46 degrees, and then side A here is 12 and a half feet. And then the other side, angle C is unknown, and then sides B and C are unknown. Okay, so we want to figure out the two unknown sides and then the unknown angle. In terms of angle C, that's pretty straightforward to figure out, right? Because for any triangle, again, the rule is that all three angles in a triangle should always add up to 180, right? And because we know both angles A and B, we can calculate angle C by just subtracting, right? So angle C has to be 180 minus 34 minus 46. And so if you calculate this, you get angle C is equal to 100 degrees. Okay, so here angle C is pretty straightforward to calculate. And then now for sides B and C, this is where we use the law of sines, right? So so because side A and angle A is the one where we have complete information on, when we calculate B and C, we want to relate it to side A and angle A, right? So so here I've used the law of sines involving A and B, right? So so this is the formula for A and B, and then I just plug the information in, right? So A is 12 and a half, angle A is 34 degrees, and then angle B is 46 degrees. And then so we just set up the equation, and then now side B is the unknown, right? So to get side B by itself, I need to multiply by sine 46 degrees over to the left side, right? So this is what I've done here. and then the rest is just a calculation, right? So so here we're working in degrees, right? So you should make sure when you do the calculation that you're in degree mode. And then again, this is just now just calculating, right? So it's 12.5 times sine of 46 degrees divided by sine of 34 degrees. And you see, I've rounded it to one decimal place, right? So the 7 makes it round up, right? So you get 16.1. Okay, so here we just use the law of sines to get B, and then to get C, it's similar, right? So so we've previously determined angle C, right? So angle C was 100 degrees, and then now the only thing that's missing is side C, right? So again, we can relate it to side A and angle A because that's the one where we know completely. So why won't this thing scroll? I don't know why this doesn't. Oh, there you go. Okay, so solving for side C is similar, right? So so I relate it to side A and angle A, and then I have a similar equation, and then we just calculate C in this way, right? So 12.5 times sine of 100 divided by sine 34. We can see is about 22. Okay, so so we've solved the missing sides and angle for this triangle. So for an AAS triangle, you can solve it similarly, except it's the first step is a little bit different, right? Because the only way we were able to get C is because we already knew the other two angles. Oh no, this isn't AAS. What's the other? What's the other one? ASA. Where you also know two angles. Okay, so it's pretty much the same in that case. Okay, so here on the next page, here we have an ASA triangle, right? Because they tell you that angle A is 48 degrees, angle B is 63 degrees, side C is 9.7, right? So I know two angles and then the side in between the two angles. So to figure out angle C again, it's similar to before, right? Because I know two of the angles, so I can calculate it by with the rule that all three should add up to 180, right? So angle C would just be 180 minus 48 minus 63. So 180 minus 48 minus 63. So we get 69 degrees for C. So this is 69 degrees, and then trying to figure out side A and side B, it's the same as before, right? So now we use the law of sines, right? So so angle C and side C is the one that's completely known, right? So say if I want to figure out A, I should relate it to C. So plugging in the information, what do we get? So A over sine 48 is equal to 9.7 over sine 69. So what does this mean? So A is equal to, so I need to multiply the sine 48 over, right? So it's 9.7 times sine 48 over sine 69 degrees. So what do we get for A? So 9.7 times sine 48 divided by sine 69. So we get about 7.7. Okay, so A is 7.7. And then what about side B? So we can do the same thing, right? So B over sine B, we relate it to C. So it's equal to 9.7 over sine 69 degrees. So let's calculate this. So the calculation is basically similar, right? So I need to multiply sine B over, which is 63 degrees, right? So B is equal to 9.7 times sine 63 degrees over sine 69 degrees. So what do we get for B? We get about 9.26, about 9.3. Okay, so we got side B is equal to 9.3. So one thing you can remember to make sure at least the calculations are on the right track is that the bigger the angle, the bigger the side is going to be, right? So you see how in this triangle, C is the biggest, angle C is the biggest, and then next is angle B, and then angle A is the smallest, right? So then comparing the three sides, it should be the same, right? So you see how side C is the biggest, and then comes side B is next, and then side A is the smallest, right? So so the angles and the sides should relate to each other in this way, where the bigger the angle, the longer the corresponding side. Okay. So that's those are the situations where you know two angles and a side. So that's sort of the easy case for the law of sines, right? So the other situation is the SSA triangle, where we said there could be 1, 2, or no solutions. So let's see what happens. Right, so how do we deal with the SSA triangles? Right. So there's a few things you want to remember, right? So again, for a triangle, all angles should add up to 180 degrees, and the sine function should always give values between -1 and 1, including -1 and 1. And so the reason that this is important is because if you get something where the sine function has a value bigger than 1, then that means that that's impossible, right? So that's the case where you have no solution. And the other thing to remember is that when sine is positive, so if you remember the 4 quadrants, right? So all students take calculus. So sine is positive in both the first quadrant and the second quadrant. And so when sine is positive, the angle can be either acute or obtuse, right? So the angle could either be between 0 and 90 or between 90 and 180. And this is the situation where there's possibly two solutions. Okay, so so from this, what you want to remember is that for an SSA triangle, if the given angle here is obtuse, then you're okay. You can just solve it exactly as we've done previously. But if the given angle is acute, that's the situation where there could be 0, 1, or 2 solutions, right? So the case where, as I said before, the case where there's no solution is when you get a sine value that's bigger than 1, right? So that's impossible, so there's no solution. And in the situation where the sine angle is smaller than 1, what you want to do is determine both theta and 180 minus theta, right? So again, the reason we do that is because the angle could either be between 0 and 90 or be between 90 and 180. So you have to check both possibilities. And then once you calculate these two possibilities, you want to check if the obtuse angle is possible or not, right? So you can check it by from the fact again that all angles in a triangle should add up to 180 degrees. If you get something where that doesn't happen, then only theta is a solution, right? So that's one solution. But if the obtuse angle is possible, then these two are both solutions. So either the acute or the obtuse. Okay. So that's the situation with SSA, right? So let's look at these different possibilities. So this is the 4th page of the worksheet. Right. So this page, I've given you three different SSA triangles, and these are all the 3 different situations that occur, right? So no solution, 1 solution, or 2 solutions. Okay, so first let's look at the no solution, right? So what are we given? So we're given that A is 11, side C is 7, and then angle C is 82 degrees. Okay, so here C is completely known, right? Because we know both the angle and side C, and then we also know side A. So let's try to figure out angle A, right? So using the law of sines again, right? So then let me write the law of sines this way, right? So sine A over side A is equal to sine C over side C. Right, so it doesn't matter if I put the angle on top or the side on top. So here I put the angles on top. So what do we get? Right, so sine A over 11 is equal to sine C, which is 82 degrees, over 7. Then the 11 multiplies over. Right, so you get sine A is equal to 11 times sine 82 degrees over 7. So sine A is equal to, so let's calculate this, right? So what do we have? 11 times sine 82 divided by 7. So we get about 1.556. Okay, so we get this. So you have to be careful about how you interpret this, right? So 1.556 is not the angle, right? It's the sine of angle A is 1.556. And then this is the situation where, as I said previously, the sine of an angle should always be between -1 and 1, right? So it should never be bigger than 1. And so this is the case where we run into this situation where the sine of the angle is bigger than 1, so that there's no solution, right? So this is impossible. So there's no solution. Okay, so any questions on this first example?
Wait. So we're just gonna leave it off as like can't solve. That's it.
Yeah, right. Yeah, it's impossible to solve because, I mean, you'll see exactly why you can't solve this, right? So, I mean, here we want to figure out what angle A is, right? So if I were to try to solve it, I would need to take the inverse sine, right? Because the angle is unknown, right? So you can see that if I were to calculate it, I would have to calculate it this way, right? So inverse sine of 1.556, but you'll see that this is impossible. So it gives you an error because it's just not possible to calculate this.
Okay, got it.
But in terms of, like, say if this were my open math, you would have to type in DNE for does not exist.
All right.
Okay.
Got
it. So again, be careful about differentiating between the angle itself and the sine of the angle, right? So what you're looking at here is that the sine of the angle is bigger than 1. That's the situation where there's no solution. Okay, so let's look at the other two cases, right? So either one solution or two solutions. So what information do we have here? So we know angle A is 88 degrees, side A is 110, and side C is 54. Right, so this is again an SSA triangle, right? So S, S, and then A. So we have an SSA triangle. So we know A completely, right? So both the side and the angle. So to get angle C, again, I can set up the law of sines. So I just write out, so sine C over side C is equal to sine A over side A. And then now we plug it in, right? So sine C. Oh, but by the way, if you look at the trig cheat sheet, it has the law of sines and cosines on the very last page, right? So this was the formula sheet that we've been using the entire time. The law of sines and cosines is on the last page, except so they still have side A, B, and C, but then for the angles they call alpha, beta, and gamma instead of the angle A, B, and C, but it's exactly the same. I mean, the reason they use the Greek letters for the angles is because you can see when I write things out, I mean, A and B are okay, but lowercase c and uppercase c looks exactly the same, right? So sometimes it's hard to tell them apart. This would be angle C, where uppercase C is bigger than lowercase c. But in any case, so let's continue, right? So side C is 54. And then angle A is 88 degrees. And then side A is 110. It's again, the 54 multiplies over. Right, so what do I get? So sine C is equal to 54 times sine 88 over 110. So what is this equal to? So let's calculate this. So 54 times sine 88 degrees divided by 110. So you see now this is okay, right? Because now I have a number that's smaller than 1. So let's say to reduce the amount of error, let's take, say, 5 decimal places here. So 0.49061. But again, this is just the sine of the angle. So to get the angle itself, I need to do the inverse sine. So what is this equal to? So inverse sine of this. Inverse sine. So instead of typing it out, I'm just going to use the previous answer that I've just calculated. So it's about 29.38 degrees, or 29.4 degrees. Let's say round it to 1 decimal place. Okay. So again, at least this part is okay, right? Because I get the sine of the angle is smaller than 1. And then to get the angle itself, I just do the inverse sine function. And so this is what I'm calling theta. Right? So the thing you want to check is 180 minus theta. Right? So you have theta, which is so you have theta, which is 29.4 degrees, right? So we also have to check. Let me check over here. So check 180 minus theta. Okay, so that's 180 minus 29.4 degrees. So what is this? This is about 150. 150.6 degrees. Except you'll see that this is impossible, right? So what is this? This is still angle C, right? So this is for angle C. And if angle C were 150, right? Angle A already was 88, right? So if you add 88 plus 150, this is clearly more than 180 degrees, and that's impossible, right? Because as we said, the 3 angles in a triangle should always add up to 180, right? So angle A plus angle C is bigger than 180 degrees, which is impossible. And so this is the situation where it's not possible to have an obtuse triangle. And so for angle C, this is the only possibility. Okay, so we know angle C, right? So this is angle C, and then now we know 2 angles, right? So A and C. So angle B is just 180 minus 88 minus 29.4. So what is that? So 62.6. So that's angle B. And what else is where we need side B, right? So side B, I can just use the law of sines. So what, A was the one that's completely known, right? So B over sine angle B is 62.6 is equal to A. What was A? A was 110, and angle A is 88. So B is, so I multiply this over. So 110 times sine 62.6 over sine of 88. So what do I get? So 97.7. Okay, so this was the case where you only have one solution because the obtuse angle for C is impossible, right? And so again, you can compare the size and angles to make sure at least there's no problems there, right? So you see between A, B, and C, A is biggest, then B is second, and then C is smallest. In terms of the angles, A is the biggest angle, then angle B is the second, and then angle C is the smallest. Okay, so that's the case where we have one solution. So any questions on this example? Okay, so let's move on to the problem where we have two solutions. So what's given in this problem? So angle B is 40 degrees, side B is 22, and side A is 30. So be careful because I've oriented A, B, and C differently in these triangles, so they're located in different places. But in any case, again, we have an SSA triangle. So side B is completely known. I know side A, so from there I can try to get angle A using the law of sines. So let's set that up. Okay, so sine angle A over A, which is 30, is equal to 20 over 22 over sine B, which is I've reversed this, right? I want the angles in the numerator. So sine angle B, which is 40 degrees, over side B, which is 22. So the 30 multiplies over. And so sine A is equal to 30 times sine 40 degrees over 22. Sine angle A is equal to, so 30 times sine 40 over 22. And then I get 0.87653. So again, we see that the sine of the angle is smaller than 1, so this is okay. Right, so this is okay. And so to get the angle, I have to do the inverse sine. So what is this inverse sine? So we get about 61.2 degrees. So again, this is theta. So I have to again check 180 minus theta. So 180 minus 61.2 is equal to, what is this? Less than 120. 180 minus 61.2 is 118.8. And so you'll see that angle B angle B plus, okay, this is for angle A, right? So this was for angle A. So angle B plus angle A is less than 180. So this is okay. So this is the situation where we have two possibilities, right? So the first possibility is that A is 61.2 degrees, and the other possibility is that A is 118.8 degrees. Right, so so 61.2 degrees or 118.8 degrees. And both possibilities are valid. So in this situation, you would have to solve each of them separately, right? So when angle A is 61.2 degrees, right? So angle C, right? So I'm kind of running out of space here. So so angle C, you would do that separately, right? So you have 180 161.2, and then what angle B was 40. So in this case, angle C would be 78.8, or angle C, in the case of the other case, would be, so you again do 180 minus 40, and then now 118.8. So 21.2 degrees. So what you have to do now is take each possibility for angle A and then continue from there, right? So side in terms of side C now, because there should be angle C, capital C. In terms of side C, again, for each of these two angles, you have to calculate side C separately, right? So again, I'm kind of running out of space, but you use the law of sines for side C, right? So you would do C over sine C is equal to relate to side B because that's where it's completely known, right? So 22 over sine 40. But again, I'm kind of running out of space here, so let me just calculate it, right? So when angle C is 78.8, what do we get? Right, so that multiplies over. So 22 times sine 78.8 divided by sine 40. So in that case, side C is 33.6. In this case, C is, again, you have to calculate it separately. So now, so 22 times, and then sine of this thing, 21.2 divided by sine of 40. So if side C were 21.2, then if angle C was 21.2, then side C would be about 12.4. Okay, so those are the two solutions, right? So you have to solve them separately because when A is different, angle C is also different in both cases. Okay, so any questions on the situation where you have two solutions? So again, the SSA triangle is the one you want to be careful about, right? So so first you have to make sure that whether the sine of the angle is smaller than 1 or bigger than 1. If it's bigger than 1, there's no solution. If it's smaller than 1, then you're okay. But then you have to get the angle and then determine if the angles are possible or not. Okay, so that's the SSA triangle, and so that's the law of sines. So what about the law of cosines? So the situations where we want to use the law of cosines, so the kinds of triangles is SAS or SSS, right? So for SAS means that you know two sides and the angle between them, and then SSS means you know all three sides, but none of the angles. So the good thing about these two cases is, again, these are the cases where you have congruent triangles. So there's only one solution in these two cases, and you can completely solve them. Okay, so where does the law of cosines comes from? So again, this is just a derivation, right? So again, basically, because the triangle is not a right triangle, what you do is you split the angle and turn it into two smaller right triangles, right? So I call the altitude y again, and then I have two different bases here. So if I call this one x, then this one has to be the whole side minus x, right? So that's b minus x. And so if I take triangle 1 here and apply the Pythagorean theorem, right, so it will be this side, this squared plus this squared is equal to this squared. So that's what we get. So c squared is equal to this thing squared plus this thing squared. And then because you have this thing squared, you can FOIL this out, right? So you get b squared minus 2bx minus plus x squared, right? So this FOILs out. And then if you look at the x squared plus y squared, that's just part of the other right triangle here, triangle 2, right? So x squared plus y squared is equal to a squared from the Pythagorean theorem for the second triangle. And so you can replace the x squared plus a squared by x squared plus y squared by a squared. Right? So x squared plus y squared turns into a squared. And then I'm just rearranging the terms, right? So a squared, I put the a squared plus b squared first, and then the minus 2bx at the end. And then finally, side x, which is this side here, can be related to angle C because it's the adjacent side for C, using cosine, right? So cosine of angle C is x over A. And then now using this to replace x, right? So the reason you do this is because you want everything relating back to the original triangle. So plugging this in for x, this is where the law of cosines comes from. Okay, so this is the law of cosines when you split angle B, but you can do the same thing by splitting the other angles in the other ways. All right, so then you get different versions of the law of cosines, and the way you decide which version to use is depending on which angle you're trying to solve for, right? So I mean, basically they look almost exactly the same, and the thing you're looking for is which angle you're dealing with. If you're dealing with angle C, you would use this one. If you're dealing with angle A, you would use this one. And if you're dealing with angle B, you would use this one. So basically, the law of cosines, you can see it looks very similar to the Pythagorean theorem, except you just have this extra term because it's not actually a right triangle. Okay, so this is the law of cosines, and again, you can use it for these two cases, right? So either an SAS triangle or an SSS triangle, and in both cases, you can completely solve the triangle. So the last page is just examples of exactly these kinds of triangles, so basically, I mean, you can use the law of cosines to figure out everything in these cases, but because the law of cosines, at least the formula itself, is slightly more complicated. Typically, the way you do these is you use the law of cosines to figure out one thing first, and then once you have that, the other things can be, the other angle can be, and the other sides can be solved in different ways. So either using the law of sines or just some other calculations. So, but I mean, you don't have to do it this way. You can just use the law of cosines for everything. It's just more calculations that way. Okay, so let's do the calculation, right? So what do we have here? So angle B is 73 degrees. Side A is 12, and side C is 22. Right, so I have SAS, and then so the other things are known, right? So, so I can figure out side B using the law of cosines, right? So again, which of the three versions you use depends on which angle you're focusing on, right? So here we're focusing on angle B because that's the one we know, right? So we want to use the law of cosines where angle B with angle B, so that's this one here. So B squared is the A squared plus C squared minus 2AC cosine B. So the way you remember is the thing squared here is the same as the angle, right? So this is side B, this is angle B, side A, angle A, side C, angle C, right? So we want to relate side B and angle B. So the formula is B squared is equal to A squared plus C squared minus 2AC cosine B, right? So again, the angle here should correspond to the side here. Then the other two sides are just coming from the Pythagorean theorem. And then the two sides here is always the same as the two sides here. Okay, so now we're just plugging in the numbers, right? So you get B squared is equal to 12 squared plus 22 squared minus 2 times 12 times 22 times cosine of 73 degrees. So B squared is equal to 12 squared plus 22 squared minus 2 times 12 times 22 times cosine 73. So that's about 4073.63. So B, so now you square root both sides to get B. But again, it's better not to round avoid rounding as much as possible because that introduces rounding error. Okay, so let me just use the previous calculation. So I get B is about 21.8 rounded up. Okay, so now I know side B. I know this side. And then again, I mean, you can continue using the law of cosines, but it's easier to now switch to the law of sines, right? So I know B completely. So now if I want to get angle A, I can switch to the law of sines, right? So sine A over A is equal to sine B over B, right? So what do I get? Sine A over 12 is equal to sine 73 over side B, which is 21.8. So what do I get? Sine A is equal to, right, so the 12 multiplies over. So what do I get? 12 times sine 73 divided by 21.8. So sine A is 0.5264. Which again is okay, right? Because sine of the angle should be smaller than 1. But that's not actually the angle, right? So to actually get the angle, I have to do the inverse sine. So what is A? So inverse sine of this thing is about 31.8 degrees. Okay, so now we have angle A, and then now we know two of the angles, right? So angle C is just 180 minus 73 minus 31.8. So angle C is equal to, so what is this? 180 minus 73 minus 31.8, which is 75.2. Okay, so this is the SAS triangle. So again, you can figure out one of the sides using the law of cosines, but once you get that side, you can switch to using the law of sines to figure out the angle. So any questions on using the law of cosines? Okay, so let's continue on to the last example. Here we have the SSS triangle where all three sides are known, but all the angles are unknown, right? So A is 14, B is 24, and C is 33. So again, we can start by using the law of cosines, but once we have that, we can switch to the law of sines. So here we don't know any of the three angles. So it doesn't matter which angle you're trying to solve for. You can choose either A, B, or C. And then you set up the correct law of cosines for that angle. So let's do that, right? So let's say we're doing angle A. Right, so for angle A, Right, so if you remember the law of cosines, the angle relates to the side, right? So this should be a squared. And then you have the other two sides. So b squared plus c squared minus 2bc times cosine of the angle, which is a. And then so now let's plug in the information, right? So 14 squared is equal to 24 squared plus 33 squared minus 2 times 24 times 33 times cosine of A. So let's calculate, or let's do some of the calculations. So you want to be careful here, right? So how does this calculate? So 14 squared. So calculate each of the individual pieces first, right? So 14 squared is 196. What is 24 squared? Is 576. What is 33 squared? Is 1089. And then 2 times 4 times 33. 2 times 24 times 33 is 1584. So this is where you want to be careful, right? So you can combine these two things together because they're just by themselves, but you cannot subtract this, right? Because it's a coefficient for cosine A, right? So we just add these two things together. So 576 plus 1089. What do we got? 1665. And then minus right, so you should think of this as a coefficient. So I need to subtract the 1665 over. Right, so what am I doing? Right, so I'm minus 1665 minus 1665. Right, so what is that? 196 minus 1665 is negative 1469 is equal to minus 1584 cosine A. So that means that cosine A is equal to negative 1469 over negative 1584, right? Because I have to divide by the coefficient. And so what does this get me? Negative 1584. So that's about 0.9274. So, but that's cosine of the angle, and it's smaller than 1, so that's okay. All right, so now I have to do the inverse cosine. So what is this? Inverse cosine. Gives me an angle of about 22 degrees. Okay, so angle A is 22 degrees. And then now we need to figure out angles B and C. right? So I'm running out of space, so let's just do it over here, right? So now we can switch to the law of sines again, right? So sine B over side B is equal to sine A over side A, right? So sine B over 24 is equal to sine 22 degrees over A, which is 14. So again, I multiply by 24. So that means that sine B is equal to 24 times sine. So again, I'm going to avoid rounding error by not using 22, but the previous calculation divided by 14. So that's 0.6413. So again, I have to use the inverse sign now. So B is the inverse sign of 0.6413. So what do I get? Inverse sign. Six, 4, 1, 3. So I get about 39.9 degrees. So that's angle B. And then finally, angle C. I can just do the 180 degrees thing again. Minus 22 minus 39.9. So angle C is equal to it's about 118.1 degrees. Okay, so I get angles A, B, and C in this way. Again, you can check that C is biggest, then B, then A. So in terms of the angles, angle C should be biggest, then angle B, then angle A. Okay, so that's the law of cosines. Are there any questions on the law of cosines? Okay, so if there are no questions, so this is the last material that we're going to cover in this class. So I'm going to post the problem set for these two sections in a little bit in my open math, and I'm going to send out an announcement regarding that. So just be on the lookout for that. And if there are no other questions, I'm going to end the lecture here.
All right, sounds good. Happy Teacher's Week.
It was a nice experience with you, sir.
Right. Thank you. And yeah, if you have any other questions throughout this week, just let me know.
Okay, will do. Thank you.
Have a good day. Stay safe, guys.
You too.
You too, Professor.